you see that the z-axis coming out of the plane, and that is the direction for the magnetic field as well. The magnetic field pointing out of the plane over there. The electric field will be this way, along the y direction. It's present everywhere, not necessarily along the y direction, but it will be there all the way. But in that point, if you consider the electric field, that will be along the y direction, and the magnetic field along the z direction. When a point charge is released at rest to begin with, for example, initially the speed is 0, and therefore the magnetic field is basically pointing this way. The electric field as well. So at the initial moment, when we release the point charge, the magnetic force is not there. It will quite obviously electrical force only. So because electrical force, what happens? This point charge will try to accelerate along the y direction, but as soon as it goes along the y direction, gains a certain amount of speed, then the magnetic force rather, also come into picture. The initial velocity is that way, the magnetic field is this way, so v cross b pointing that way, which implies now there's a force along the x-axis as well that will change the velocity a bit. The velocity changes, tilts a bit. It also is a small number, but nevertheless it also tilts a bit. So once it tilts, the direction of the magnetic force changes as well. So the speed will increase definitely, but tilt more. So that is what is going to happen. But the question is, it's very difficult to determine right now, I mean, at least directly using this way, exactly how much will be tilt and what path it might take over there. We can approach it mathematically, but the important thing to understand over here is the velocity will be entirely on the xy plane always, and therefore trajectory as well will lie on the xy plane only. The reason being the fact that the magnetic field is in the z direction, so there cannot be any deflection in the z direction or any force in the z direction as well. That is why it never goes in the never goes beyond the xy plane actually. So if we try to approach it, I mean, say in an analytical manner, we might, for example, at any point of time, assume that the velocity is having the two components vx I cap plus vy j cap, in which case I could write down the net force acting on it at this particular moment. There are two forces. One is electrical force, which act along the y direction. The other one is a magnetic force, which will be determined by qv cross b. So if I just look at the net force acting on the object, it will be, first of all, electrical force as qe along the j cap direction. Then the magnetic force, which is going to be q into v cross b, which is vx I cap plus vy j cap cross with b along k cap. If we cross them up, we notice that we get qe along j cap. Now I cross k is nothing but minus j, so I get minus vx b j cap, and j cap cross k cap is nothing but I cap, so I get plus vy b along I cap, and club them together, so we have q into vy b along I cap plus q into e minus vx b along the j cap. Okay, but then F is nothing but, I mean, F can be written down as mass of the object, mass of the point charge into ax I cap plus ay j cap. That is what we have. So you can equate them, the x and the y components, and end up getting a couple of equations, two equations in fact, which gives us the first one says that ax over there I can divide by m, so I get ax equal to qb by m into vx, and AY will become Q by M into E minus QB by M into Vx. That's what we have in this case. Oh, sorry. Vy. Yes, that's right. So these are what we have. Ax is nothing but dvx upon dt by the way. If I can just write down in terms of derivatives, we can write down therefore at this point that dvx upon dt. You see, qb by m is nothing but the angular frequency or the cyclotron frequency actually. So you can write it in terms of qb by m, which is nothing but cyclotron frequency, write as omega into vy, where omega is a cyclotron frequency qb by upon m. Okay, and similarly dvy is visible. I'll write over there. Let's come up with that. Omega into vy and dvy upon dt is, I could multiply and divide by b so that I get omega into e by b. This one I have multiplied by the b over there, and minus omega into vx. That is what we have got, the two equations in terms of above the graph. Above the graph implies, is this not visible, Samvrata? Okay. So that is what we have got. In this case, we have a very interesting pair of equations where the rate of change of Vx depends on Vy and the rate of एक्शन कैसे लिखे, नेट फोर्स इक्वेट किया यहाँ पे है ना, नेट फोर्स को इक्वेट किया एक्स कंपोनेंट को एक्स कंपोनेंट के साथ, वाई कंपोनेंट को वाई कंपोनेंट के साथ, isn't it? दो पायन, हाँ ठीक है, तो वहां से फिर एक्स निकाला और वाई निकाला एम से डिवाइड करके एक्चुअली, और एक्स dvx by dt है तो उसको लिख दिया, और y dvi by dt है उसको भी लिख दिया. अभी इनको सॉल्व करने का क्या तरीका, क्या करोगे, डिवाइड करके रिथ्रो. व्हाट हैपेंस इफ यू डिवाइड देम, you will get what? You get dvx upon dvy equal to vy upon e by b minus vx. Will that be useful? Relation between vx and vy. So you just get something like dvx upon dvy equal to vy upon eb minus vx. That is what we have got. Upon integrating, how do you integrate that, by the way? Oh, you are going to just saying, we already know the relationship by the vx square plus vy square. Oh, that's the speed square that you can obtain by what Aish did earlier. But that will not give us a trajectory, will it? If you integrate them up, you simply end up getting something like vx square plus vy square. What do you get, by the way? Dvx upon dvy equal to that thing. So we can separate. We can, well, yes. You could, in this case, I mean, integrate by separating the variables. If you divide and then do that. Yes, initially they are 0. वही आएगा, अच्छी बात. You see, these are actually examples of a coupled differential equation. We call them as coupled differential equation because of the fact that they, the rate of change of one quantity depends on the other one. इंडिविजुअली 2 बार इंटीग्रेट कर सकते हैं। किसको कैसे करोगे? यश, इधर में रेट ऑफ चेंज ऑफ Vx और यहाँ पे Vy है, कैसे इंटीग्रेट करोगे? हाउ डू यू इंटीग्रेट, यश? These are example of coupled differential equation. हाँ, तो यहाँ से तुम क्या कर सकते हो ना कि Vx स्क्वायर को एक तरफ ले, Vx को एक तरफ ले आओ, फिर स्क्वायर कंप्लीशन कर लो, तो तुम्हें Vx स्क्वायर मीन Vy स्क्वायर प्लस Vx माइनस E by V होल स्क्वायर इक्वल टू E by V होल स्क्वायर मिलेगा। उसके बाद क्या करोगे? विथ रिस्पेक्ट टू एक्स Vy कांस्टेंट, ये सी क्या बोल रहे हो? Vy कैसे कांस्टेंट होगा? Vy कांस्टेंट और निकालने का फिर तो मतलब बात ही खत्म हो गया। Vy कांस्टेंट है तो फिर तो y कोड सिंपली लीनियरली इंक्रीज करेगा टाइम के साथ, अब x निकालेंगे वैसे। No, don't worry, let me just tell you what I was saying is these are examples of something called a coupled differential equations. It's quite obvious why they're coupled. They're coupled because the rate of change of one depends on the other, rate of change of the other depends on the first one. That is why they are coupled in this case. So the way that we have to solve it will be to first decouple them. Implies that we'll have to separate them somehow, so that the rate of change of one quantity depends only on that quantity, not the other one. And that in this case can be done. We can decouple them effectively. However, there needs to be a price which has to be paid. And the price paid in this case is an increment in the complexity, increment in the order of differential equation. What you could do, for example, is differentiate the second equation with respect to time. When you do that, this side we get dvx by dt, which I can eliminate from there. So in that case, I'll get an equation which contains only Vy actually, and the other way around as well. So what I do in this case is we need to decouple them, and the way that we do it is by differentiating the second equation once. With respect to time, we end up getting d2 Vy upon dt square equal to minus omega into dvx by dt. But dvx by dt is omega into Vy, so I get this. देख लो है just कैसे किया. I said differentiate the second equation or the first equation, doesn't matter. Differentiate the second equation with respect to t, and I end up getting this one. I replace dvx by dt from that equation as minus omega square into Vy. So we end up getting the equation d2 Vy by dt square equal to minus omega square into Vy. This equation seems familiar by you? Does this equation seems familiar? d2 Vy upon dt square equal to minus omega square Vy. Does this equation seems familiar a bit? Exactly. It is nothing but the SHM equation actually. Yes. So in this case, therefore, Vy performs SHM actually. And therefore, we can write a solution for Vy directly. Vy becomes something like a cos omega t plus phi. Once I have got Vy, I can go back over there, integrate or you could simply use this equation to obtain Vx as well. So we know Vx and Vy with respect to time. So just come back to this one later on. We know the question you have read. I hope this was given in the WhatsApp group. Once you have got this, I can write down directly. Therefore, Vy is something like A into cos omega t plus phi. We shall evaluate those numbers in a moment. नहीं ऐसा नहीं है सम्यक, ऐसा नहीं है. It is this particular condition when E and B are mutually perpendicular and they have I may say the point charge release at rest. Only then this can be done. Okay. Once you've got this Vy, I can use this equation over there to obtain Vx as well. So we get Vx as what? From this equation, I get therefore Vx. Vx will be given by E by B minus 1 by omega dvy upon dt. That gives us E by B minus, to differentiate dvy upon dt, I get a sine omega t plus 5 with minus sign, and omega is coming up as well, so it will cancel out. So we get E by B plus A into sine omega t plus 5. These are what we have got, Vx and Vy. So I can use now the initial conditions. We know that t equal to 0. At t equal to 0, Vx is 0 and Vy is 0 actually. So from there what I can get? That will give us in this case Vy is 0, so I get A cos phi must be 0. And that will give us E by B plus A sine phi equal to 0 as well. So if I wanted A cos phi to be 0, obviously A is not 0, so cos phi has to be 0. So phi has to be there for either plus pi by 2 or minus pi by 2. If I take, however, pi by 2, then obviously A becomes negative. So I do not take pi but minus pi by 2, but minus pi by 2 actually. So we end up getting therefore from here pi equal to minus pi by 2, and therefore A will turn out to be E upon B. Once you've got that, I can just put back, and therefore we obtain Vx as E by B, and this will become E by B sine omega t minus pi by 2, but it is minus cos omega t actually. So I get minus cos omega t, while Vy turns out to be A cos omega t minus pi by 2, which is same thing as E by B into sine of omega t. These are the velocities that we've got so far. Once you have got the velocities, which can quite obviously Phi, yes, Virendra, I said that I needed in this case a cos phi to be 0 and e by b plus a sin phi to be 0 as well. Now, because a is not 0, so cos phi must be 0. If cos phi is 0, then I'll get phi to be odd multiple of pi by 2. And normally, you just take either pi by 2 close enough to 0. Pi by 2 or minus pi by 2 you can take. If I take pi by 2, then a sin pi by 2 will becoming a. So I get a plus e by b equal to 0. So a becomes negative. But we don't want a to be negative because a is technically the amplitude. So I don't take a negative. Instead, I take phi equal to minus pi by 2. So if I take phi is minus pi by 2, this will be valid. And from here, I'll get a equal to e by b, which is a positive number, and therefore will be allowed. That is why I have taken phi to be pi by minus pi by 2. Okay. So we end up getting Vx and Vy from there. Once we know this Vx and Vy, you can obviously integrate it up as well to obtain the x and the y coordinates. If I integrate this one, e by b into t minus cos omega t, the integral must be done from 0 to t actually. So that becomes sine omega t by omega. If I just put the limit, I end up getting simply sine omega t by omega t. So this will actually give us, in this case, from here, we get the x coordinate as e by omega b into omega t minus sine omega t, and the y coordinate sine omega t integral becomes minus cos omega t by omega, limit is 0 to t, so we get 1 minus cos omega t. So I get e by omega b into 1 minus cos omega t. These are the x and the y coordinates we're getting over there. They will parametrically determine the curve. Obviously, from there, if I eliminate t, I'll be able to obtain the equation of the trajectory. But in this case, elimination of t will be a bit complicated. It will be involving the inverse function. So it will be useful to just let it be like this in terms of the parametric form. So it is nothing but the parametric form of the curve over there. I have another question arises, exactly what the curve is. Exactly, curve किस तरह का हो सकता है, उसको देखने के लिए थोड़ा वेट करते हैं. वैसे तो हम लोग प्लॉट कर सकते हैं. Is nothing but a parametric curve over there. But before actually looking at it as mathematically, let us take an alternate view in this case, and that will give us not only the perspective. SHM कैसे logically, SHM कौन कर रहा है? Velocity SHM harmonically change कर रहा है. Obvious है क्योंकि इलेक्ट्रिकल फील्ड उसे एक्सीलरेट कर रहा है, बट मैग्नेटिक फील्ड बेंड करता जा रहा है, तो उसका वेलोसिटी बेंड करते करते एक बार इतना ज्यादा बेंड कर जाए कि वो बेसिकली वापस हो जाएगा एसेंशियली. मैग्नेटिक फोर्स से टुवर्ड्स द राइट बेंड करता ही जा रहा है, बट जैसे वेलोसिटी बेंड हुआ हल्का, ऐसा फोर्स भी बेंड हो गया तो और ज्यादा बेंड करेगा. तो ऐसा करते करते टाइम के बाद वो Vy 0 हो जाएगा और फिर वो वापस आने लगेगा. और जैसे रिवर्स होने लगेगा तो इलेक्ट्रिक फील्ड से रिटार्ड करने लगेगा, तो फिर वो अल्टीमेटली एक पॉइंट पे जाकर रुक जाएगा. What is meaning of trajectory will not go to infinity? What is implying that? What do you think? If I take the trajectory as parabola, by the way, will it go to infinity in that case? It is not a parabola, but I'm just saying that if it was a parabola, will you take it to be going to infinity? Okay. In this case, in that case, it somehow goes to infinity as well if I allow it to move for sufficiently long time. But the y coordinate is bounded essentially. You see, the y coordinate will be bounded. It can never exceed twice of e by omega b. But the x coordinate is unbounded. I mean, as time increases, sine omega t will repeat, but omega t will not. So as t increases, x will keep on increasing indefinitely. Well, Abhinav, I will not say sinusoidal, but Okay, it will possibly seem something like that. But before guessing it up, let us take up an alternate view of the same problem, and that will give us a physical way of interpreting the trajectory as well. Okay. Now remember the question in this case we had in this case transverse electric and magnetic fields along the x and the y direction. Y direction contains a uniform electric field E. Z direction contains uniform magnetic field B. And a point charge is released at rest at the origin. Okay. Okay. Now you see that in this reference frame we do have both E and B present. But earlier I said that by transforming the reference frame, we effectively change the electric field in our reference frame. So what I just do in this case is take up another reference frame, a new reference frame, which is moving in this case in such a way that in that reference frame E turns out to be 0. Remember that we had obtained earlier that E prime vector is given as E vector and plus V naught cross B vector, where V naught was the velocity of the reference frame. Okay. In this case, if I choose the reference frame to move because the B field is coming out, I want V naught cross B to be pointing down so that they might be opposite to this given field, and then we can have a chance to make it 0. Okay. So we notice in this case that V naught, if I take it this way, V naught cross B, B is that way, V naught is this way. So V naught cross B is actually coming down over there, which implies I could in this case take up another reference frame which is moving. We take a different reference frame, let's call it as S prime, which is moving this way with a speed V naught in such a way that V naught is equal to E by B. V naught, you notice, is moving this way, then B is coming out and V naught is that way, so V naught cross B is pointing down, which implies the opposite is E up over there. So that by suitably choosing the speed, I can make the net field vanish in this reference frame actually. So what happens is if I choose this to be E by B, if I select the reference frame S prime, which moves in such a way that the speed is positive, I mean say E by B, and it is moving along the positive x axis. In that case, what we find is that the electric field in this new reference frame is 0 because the B cross B will point downwards and the magnitude is exactly equal to E itself. So in this new reference frame, what I find is that E vanishes. So in this new reference frame, there is no E. Well, I could have written up both. In this S prime, the net E is 0. In this E prime, I find that in S prime, we essentially have only a magnetic field present actually. Okay, so in S prime, if I now see the situation, what do we see? So in S prime, the situation that we see is that there is no electric field, only a magnetic field present in this direction. There is no electric field. The magnetic field is pointing in the outward direction, and the magnitude is just a constant. However, in this reference frame, this charged particle which was in this reference frame released at rest from the origin, it will not be at rest. In fact, in this reference frame, what I see is that the point charge is projected. That's tilted. Let's just horizontal a bit. No, a bit horizontal. No. Okay, so in this reference frame, the point charge is not released at rest. Rather, the point charge is actually projected this way with a speed which is equal to V naught itself. Okay. So what will be the path in this reference frame, by the way? Quite obviously, in this reference frame, the path is simply a circle. Why? Because there is no electric field, only magnetic field. A uniform magnetic field is what we have. So the point charge just follows a circular path. And that circular path will look in what sense, by the way? I mean, because V naught is this way and B is coming out. So V naught cross B is in fact up, which implies the initial force is upwards. So the center must be somewhere over there. It has to just move along a circular path like this. Suppose it is circle. That is how it moves in this reference frame. Okay. S prime. Well, Riddhi, मैंने बोला कि S prime एक ऐसा रेफरेंस फ्रेम हमने चूज किया है जहां पे और जिस रेफरेंस फ्रेम हम चाहते हैं कि E0 हो जाए. लास्ट क्लास में ऑब्टेन किया था कि if it is a reference frame, then the electric field changes and the electric field is given by that equation. It is the original electric field in that reference frame plus an additional quantity which is V naught cross B. So I'm going to choose V naught cross B in such a way that V naught cross B turns out opposite of the electric field and exactly equal to that. Okay. So in this system, what happens is once I choose the electric field V naught to be E by B, in that case, in this new reference frame that you have got, the electric field is simply vanishing. There is no electric field, only a magnetic field which is pointing in the outward direction. But in this reference frame, originally the point charge key was placed at rest at the origin. But in this reference frame, it will not be placed at rest because my reference frame moves this way, then the point charge will have velocity this way, isn't it? Initially. So it is in this reference frame, it seems not pseudo force, it's a relative motion. There is no pseudo force, it's an inertial reference frame. V naught राइट की तरफ है, इसलिए उसके रेफरेंस में पॉइंट चार्ज का वेलोसिटी किधर दिखाई देगा? पीछे की तरफ. That is why towards left. Okay, yeah, it is towards the left. Fine. Why? Because original frame में वो इधर पॉइंट चार्ज रेस्ट पे क्या था, इसलिए इसके रिस्पेक्ट में पीछे की तरफ जाएगा, है ना? So therefore it has got a velocity in the backward direction. तो इस रेफरेंस में क्या दिखाई दे रहा है कि एक पॉइंट चार्ज को एक यूनिफॉर्म मैग्नेटिक फील्ड में परपेंडिकुलर डायरेक्शन में यूनिफॉर्म स्पीड v naught से प्रोजेक्ट किया है. तो इस कारण से इस रेफरेंस में क्या दिखाई देगा? वो एक सर्कल में घूमेगा क्योंकि that is what the motion is when we project it in a uniform magnetic field, isn't it? So इस रेफरेंस में क्या दिखाई देगा कि v naught जो पॉइंट चार्ज जो है वो सिंपली सर्कल मूव करेगा. इसका सेंटर कहाँ पे, रेडियस कितना हो जाएगा? The radius is going to be mv naught by qb, which is m by qb. Qb by means omega, so I get v naught by omega, but v naught is what? V naught is e by b, so I get basically e by omega into b. That becomes, is visible, it is e by omega b, that becomes the radius. So the radius is known over there and the direction of motion is this way with the speed of v naught. Okay, now what will be the path obtained when I go back to the original reference frame? You see that with respect to the original frame, I can write down the velocity of the charged particle at any point is equal to sum of two velocities. One is the velocity of the point charge with respect to velocity of the point charge with respect to s becomes that of the point charge with respect to s prime plus that of s prime with respect to s, which is nothing but v naught. This one is simply v naught vector fixed vector. So ऐसा इस रेफरेंस में इसलिए क्या मिलेगा कि अगर वापस हम ओरिजिनल फ्रेम में आते हैं तो पाथ ऐसा ही होगा जैसे कि हर पॉइंट पे हमें जो पॉइंट चार्ज का वेलोसिटी s प्राइम के रिस्पेक्ट में सर्कल में घूम रहा है, तो हर पॉइंट पे वेलोसिटी टैंजेंशियल होगा और उसमें एक कांस्टेंट स्पीड ऐड करना पड़ेगा, वो होगा s का वेलोसिटी मतलब v naught. तो इसमें क्या हो रहा है कि if we just transfer it back to the original frame, the path will be, the motion will be as if we are adding at every point two velocities. One is v naught tangent to the path, the other one v naught which is parallel to the x-axis. Exactly. In this case, this is therefore almost, it is in fact the same thing, or it is a motion of a same as a particle on the wheel, on the periphery of a wheel. By the way, if you just take a rolling wheel, a wheel which rolls on the ground, we know that every point have got two velocity. One is the velocity center of mass, and the other one is a tangential velocity which is equal to v naught itself, the center mass velocity, if the pure rolling condition is fulfilled. which implies in this reference frame, therefore, the path is as if there is a point on the periphery of a wheel, and that wheel on the ground with a pure rolling motion essentially. So what will that be? By the way, we have already seen the motion of such a point. And in case of rotational mechanics, we saw that when a wheel rolls on the ground, any point on the periphery undergoes in what path, by the way? You remember? That path was a cycloid, in fact. So is current say the path of the point particle in this case will be simply a cycloid if I see in this reference frame, and that cycloid is going to be obtained by allowing a wheel to roll whose radius is equal to this r, and therefore the path will be in this case something like E by B over here, so it will be like this. That is how the path looks like actually. It is a cycloid, in fact, which is obtained by allowing a wheel of radius E by omega B to roll along the x-axis. Okay. In fact, once I have got this, I can actually get the equation as well. We can in fact find that both the velocity and the position if we know this. जब तुम साइक्लॉइड का एक्सप्लेनेशन याद नहीं क्या तुम्हें आता है शार्प पॉइंट से प्रॉपर्टी है साइक्लॉइड का mathematically just look at a derivative, it vanishes at those locations but never शार्प पॉइंट वहां पे इसलिए क्योंकि जस्ट उसके पहले वो नीचे की तरफ मूव कर रहा होगा अब्रप्टली, उसके बाद वो ऊपर तरफ मूव करने लगेगा. यहाँ पर फील्ड में कैसे मतलब क्या होता है? What do you mean that? हाँ यश, मूविंग रेफरेंस फ्रेम में उसका पाथ एक सर्कल है जिसका रेडियस हमें पता है और स्पीड v0 से मूव कर रहा है. वापस अगर ओरिजिनल फ्रेम में हम आते हैं तो हम लोग को हर पॉइंट पे एक वेलोसिटी ऐड करना पड़ेगा टुवर्ड्स राइट. मतलब ऐसा ही हो रहा है जैसे कि वो एक कांस्टेंट यूनिफॉर्म वेलोसिटी हम लोग हर पॉइंट पे ऐड कर रहे हैं. तो हर पॉइंट पे दो वेलोसिटी होगा, टैंजेंशियल और एक टुवर्ड्स राइट, जो कि वैसे सिचुएशन होता है जब एक व्हील रोल करता है ग्राउंड में प्योरली. जब ग्राउंड में प्योरली रोल करता है व्हील तब भी यही कंडीशन अराइज करता है. हम लोग को हर पॉइंट का वेलोसिटी फाइंड करने के लिए we need to add up the center of mass velocity to every point. Center of mass velocity is constant. तो उस केस में यहाँ पे वही कंडीशन निकल रहा है. v नॉट को हम सेंटर ऑफ मास वेलोसिटी से ट्रीट कर सकते हैं और हर बार टेंजेंशियल वेलोसिटी ऐड अप करते जा रहे हैं. So that gives rise to a cycloidal path that we have seen earlier in case of rotation. That is why in this case, in the original reference frame, the path becomes a cycloid. Okay. Yes. In terms of fields, what is the meaning of that, by the way? We know in this case that Vy turns out to be 0 because the electrical force will do negative work once the path returns back. Once the path starts this way, the electrical force is going to do negative work. And that is why it is able to bring the speed to be 0 abruptly. That is why we're getting those points where the velocity is abruptly 0, y velocity. Immediately before it was pointing down, immediately after it's pointing up. Okay. You can actually, I was saying, write on the velocity and the position as well. If I, without actually solving the differential equation, the point in this case is that once you have reduced this result, then any point after, say, it was initially at the origin, so after some time in this reference frame, it will go somewhere over there. This angle is omega t then. This is the situation in this reference frame at time t later. So I notice in this case that the velocity is basically pointing this way with respect to the center, and there's one more velocity this way, which is because of the center of mass motion or that particular v0. In this case, we can write down there for the x velocity if I want it from this one, as the equation suggests. Or you can just see that x velocity of the particle will be, with respect to this s over there, will be हाँ Vy 0 होगा तो, अदरवाइज फिर वो शार्प होता ही नहीं ना. Vx non-zero but Vy 0 हो गया. So as you can see from here that the x velocity can be obtained as the velocity of the center of mass, and to that I add the velocity of this point in x-axis, which is negative component. This angle is 90 minus omega t, so this becomes omega t. So I get v naught cos omega t. This was becoming vx. V naught was nothing but e by b. So I get e by b into 1 minus cos omega t. That is what vx is, which I have got a bit earlier over there by using differential equation, isn't it? In similar fashion, if I want vy, that I can also obtain, because vy will obviously be unaffected by the center of mass motion. So vy is going to be simply the component v naught in this direction, which is v naught into sine omega t. So that is to say, we get e by b into sine omega t. These are, we have got vx, vy and vx from this circular motion or this cycloidal motion. Not only that, we can also look at the coordinate, by the way. First of all, with respect to center, if I consider center of the circle, the x coordinate is negative, it is equal to r sine omega t, and the y coordinate is also negative, positive, it is r minus r cos omega t. With respect to the this diagram, if I look at the x y coordinate of this particle, x coordinate implies this distance, so it's negative, and that will be essentially the projection of r on this line, which is nothing but r sine omega t. That is with respect to the center actually. With respect to center, if I look at the position, then with respect to center, the position are going to be coming up as minus r sine omega t. To that I must add the center of mass displacement as well, but that will be nothing but v naught into t. So I get in this case therefore the x coordinate as v naught t minus r sine omega t, while the y coordinate is simply this length, which is capital R minus r cos omega t. So I get capital R into r minus r cos omega t. That's what we have. However, these two lead to the same set of equations because of the fact that v naught is e by v and r is e by omega v. So if I just put them over there, I will exactly get the same set of equations. Okay, that is why in this case we can actually obtain those equations without in fact solving differential equation as well. We could